Hey everybody, Mr. Monahan here going through the 11B practice test. Take a look at these, watch every question, watch just the ones you know you have wrong, whatever you need to do to get yourself ready for the test. Question number 1 is matching the volume formula with the solid. If you have all the formulas in the right place, the formulas in this half of the chapter should probably feel a little bit easier than the surface area ones. As you can tell, they're a lot less complicated. So when you talk about volume, just make sure you know what shape you have, and then make sure you know that you have the right kind of heights and those types of things. We'll get to that in a little bit. The volume of a prism, well, here's a prism right here. It's got a base and another base parallel to it. It's got a distance between the bases, which is a height. To find the volume of a prism, you need the area of one of the triangles times how tall it is. So this is just capital B times H. That would be option C. Cylinders have two bases as well, but they are circles, so it's going to look a lot like this formula, but instead of B, we know what the area formula of every base of a cylinder is, which is pi r squared. So pi r squared times H is going to give you the volume of a cylinder. Pyramids now, these are the pyramids and cones are the ones with 1/3 in it. They're 1/3 this, so a pyramid is 1/3 the size of a prism. A cone is 1/3 the size of a cylinder. So pyramid is the exact same formula as prism except for 1/3 of it, so that would be D. Cone is 1/3 of pi r squared times H, which is E, 1/3 of the cylinder formula, which leaves spheres. That's the complicated one, 4/3 pi r cubed A. Make sure you know all those formulas tomorrow. If you know the formulas, it should be pretty quick to plug everything in. All right, so let's try using them. So we have a prism here. It says it in the directions, so we're going to do the volume of the prism, capital B times H. Okay, well, H is going to be this 15 right here. All right, so we know that H is 15. We got to figure out capital B this time. Capital B is representing the area of this triangle, which is 1/2 base times height. So now I'm talking about the small b and the small h. So now I'm talking about just this triangle. Base of 12, height of 8. So we have 1/2 times 12 times 8, which should be 48. So capital B is 48, h is 15. We can get the volume then by doing capital B, 48, times 15 and getting our answer. Let's see if I can get, oh, I forgot to pull the calculator up. 1 sec. All right, so there's the calculator. We have 48 times 15, and we get 720 for our answer. So we would go in, we'd put 720. They already have the units in there, but we have cubic units for volume. Okay. Next one is actually the same formula, since we still have a prism. With these, with a box, I mean, it doesn't matter what capital B is. You can do 7 times 5 and say the base is the bottom. You can do 7 times 4 and say the base is the front. You could even do a combination of those. You could do the right-hand side. You could do 5 and 4. Long story short, it doesn't matter. When you have a box, let's say we do use the bottom, 7 times 5 would be the base, and then the height would have to be 4 then. What's happening is you're just multiplying all three numbers together. So in this instance, it looks like we have 140, and we're at cubic meters. So 140. So if it's a box, just multiply all three numbers up. All right, this one is a regular polygon, so the capital B formula is that part's gonna change here. So let's see if I can get that faster. So this one, what's gonna be different is we're going to use, for our capital B formula, we have to use, oh, go away. You have to use 1/2. Oops, there we go. I'm struggling with this. All right, 1/2 ASN to get capital B. All right, so capital B here is going to be a regular hexagon, which is why we have the 1/2 ASN formula. They did tell us that and H is going to be 10 for this problem, because 10 is how far the hexagons are away from each other. All right, A they gave us as 3.5. S they gave us as 4. And we know there are 6 sides in a hexagon. So we're going to go to the calculator. We're going to do 0.5 times 3.5 times 4 times 6. I'm just going to put that in as 24 to save time. So we know that capital B is 42. We already know that H is 10. So the volume of this shape is capital B times H, 42 times 10, which is 420, I forget the units already, cubic yards. All right. So that's our prisms. All right, we're going to move on to some other shapes now. Looks like cylinder is up next. All right, so this one's asking for volume of a cylinder, and it's saying in terms of pi, which means we have a little bit less calculator work to do, so that's good. The formula we said from before, it's still B times H, but B is always going to be pi r squared. So we have pi r squared times H. That's always going to be our formula for this. Okay, so then for this problem, they gave us H is 12. But they didn't technically give us what R is. They gave us 10, but notice how the it's drawn all the way across here. So 10 is a diameter, which means 5 is a radius. All right, so what we have here is 25 pi, 5 squared, times 12, which should be 300. So we have 300 pi. They said leave it in terms of pi, so we don't need to punch that into the calculator. We are done. Next one doesn't give you a picture, but that shouldn't cause you too much grief. They just want you to plug everything in from what they tell you. So we know that the radius is 20, so I'm going to put that in right away. Pi times 20 squared. They tell us the height is 32. And they ask for the volume in terms of pi. So we're ready to figure out the answer already. So 20 squared is 400. So we need to do 400 times 32. And then that will be our answer in terms of pi. So 12,800 pi is our answer. Our unit is cubic inches, and we are good to go. Okay, so that's cylinder. Let's move to a new shape, volume of pyramids. Now pyramids can have the correct dimensions or the incorrect dimensions, so we'll talk about that right now. Okay, so what I popped up on the screen now is the correct formula for pyramids. 1/3 of a prism. So 1/3 of base times height, capital B, is area of the base. So if it's a square, not so tough, but other things can happen, which I'll show you. The height that you want for volume is the inside height. So remember back to surface area, we always wanted to get this one. That was called L. We don't want that this time. So you can see number 8, we're going to have to talk about that. But this is the correct height, so this is H. So we know that 12 is H. Okay, so we need to do 1/3. We need the area of the base, and then we know that the height is 12. So the base is a square, so we have a 10 by 10 square. So the area of, or capital B, I should say, is found just by doing 10 times 10, or this is 1/3 of 100 times 12. All right, or 1/3 of 1200. All right, 1/3 of 1200 is 400. So 400 cubic millimeters would be our volume. Okay, that's if they give you the correct height. Remember the 1/3. People forget the 1/3 all the time. Okay, the next question is a little bit one step tougher because we still have the same formula. All right, the base part isn't hard. So we have 1/3. The base is 6 times 6, okay? But the height is what we don't know this time, okay? Because we don't know this height right in here, the altitude from the very top straight down to the center. 8 is what we would call the slant height, or L, this time. So we need to kind of go off to the side here, and we need to find what the height of the pyramid would be. So, and the question even reminds you to do that. We don't have H, so we need to find that. So the way we do that is with Pythagorean theorem. So imagine this. What we know is that this is 8. And then down here, we're doing this triangle right here. This bottom side, which is going to be here, isn't 6. The whole distance is 6, so this is going to be half. A lot like what we did last chapter. This is going to be 3. So we need to find h. So we know h squared plus 3 squared equals 8 squared, which is h squared plus 9 equals 64. So h squared equals 55. So we need to do the square root of 55. And we could leave that until the end. Maybe I will. So that we don't get too rounded here. Okay, so h is the square root of 55. So let's actually put that in as 7.4, which is the square root of 55, as you can see there. So we have 7.4. We just need to go and plug all this stuff in. So I already have the square root of 55 in. Let me actually do this. We're supposed to do 1/3 times the base, area of the base, which is 36, times the square root of 55. So looks like for our answer there, we're really stinking close to 89. So what we have here, actually when I round it, it says to the nearest tenth. When I round that, 88.99. If you round that to the nearest tenth, then the second 9 rounds up. So this actually does round to 89.0. So that's the answer that I would put in, 89.0. Okay. Now, so if they have the correct height, the inside height, go right to the formula. If they give you the slanted height, you need to do Pythagorean theorem first. All right. This third pyramid problem is just to show you that it doesn't have to be a situation where it's a square on the bottom. So capital B isn't always just 10 times 10 or whatever it was that we had. So let's go through this process. We have 1/3, capital B, which we'll come back to in a second. H, we check, we make sure that 28 is the inside height. This time it is. So now we're trying to figure out what goes in here. Okay, well, this is a hexagon on the bottom. So the formula for that is 1/2 ASN. Okay, side length is 16. N is the number of sides, which is 6. Did they give us the apothem? Well, not here, but yes, they did up here. So it's 8 square root of 3. So let's do some punching in. 1/3 times 1/2, 8 square root of 3, times the side length, which was 16, times the number of sides, which was 6. All that is going to be multiplied by 28. Okay, let's do just the capital B part in the calculator first. So we have 0.5, we have 8, times 8 square root of 3. And then we're going to multiply that by 16, and we're going to multiply that by 6. All right, so we're going to say that all of that stuff is equal to 665.1. And I'll even go 0.11. That 7 here would round this next digit up to a 1. Okay, all of that needs to be multiplied by 28. Okay, so let's do that. 1/3 times 665.11 times 28. Okay, so there's our volume total. We have 6,207.69. That would round up to 0.7. And I think this one said nearest tenth again. So, yep, it did. So 6207.7. All right, awesome. Now we're getting into a couple of them where there's really more than one shape in the picture. They're composite shapes. So when we go through and try to figure out that, there's really 2 steps that we need to take. Okay, so let's think about this one first. There's a cone here and there's a cylinder. If I want to find the volume of them, this is easier than the surface area version because I had to think about with surface area what was on the surface and what was on the inside. I'm just going to take the volume of the cone, the volume of the cylinder, add them together. Okay, so first thing I need to do, it doesn't matter what order, I guess. Let's do the volume of the cylinder first. Okay, that has a formula of pi r squared times h. They told us r is 9. We know that h is 15. So pi times 9 squared times 15, which is 81 pi times 15. Let's get what 81 times 15 is. 1,215. So that's a number that I need. Okay. I also need the volume of the cone. Let's do a different color for that. This has a formula of 1/3 pi r squared times h. So r should be the same. This r should be the same as this r. So r is going to be 9 again. So we have 1/3 pi times 9 squared. And the height this time is 12. We check it is the inside height, not the slant height. So that's the good version. We want the inside height for this chapter. So that's 1/3 of 81 pi times 12. If you think about the 1/3 and the 12, 1/3 of 12 is 4. So I could do 4 times 81. Or you could punch it all in and get 324. So this will be 324 pi. Okay, so then we're ready to get our answer. We need to combine those two things. So I'll do my answer kind of over here. So our answer is 1,215 pi plus 324 pi. And that'll be what our final answer will be. So let's do our 324 plus 1,215. So, oops, one too many numbers. So we have a total of 1,539 times pi. So we get the two separate volumes, we add them together, and we are done. 1,539. Okay. All right, this one is a box on the bottom and a box on the bottom and a pyramid on the top. So the box should be really fast. The volume of the prism on the bottom, I probably shouldn't call it a box, is, so again, like we talked about, with a rectangular prism, or this is actually a cube, base times height, 10 times 10 times 10. So the formula would be capital B times H. 10 times 10 would give us B. H is also 10. The volume of the prism is 1,000 cubic meters. Okay, we need that number. We'll hang on to it. The volume of the pyramid is 1/3 of capital B times H. Capital B is the same as this base, which is 10 times 10. So 10 times 10 would be 100 again. And H is 13. It is the inside height, so we're good there. Looks like we're headed toward a decimal here. We have 1/3 of 1,300. So let's figure out what that is. 1/3, so 1,300 divided by 3. So this one has a volume of 433.33 cubic meters. So we're ready to get the total by adding them together. So we're doing 1,000 plus 433.33. Well, that's just 1,433.33 cubic meters. A lot of threes right there. So they want nearest tenth, so I'm just going to chop off that last 3, 1433.3. So that's how you do composite shapes, volume of the top plus the volume of the bottom. Okay, now we're back into cones. We haven't talked about cone yet. So those have a pretty simple formula. Their formula is 1/3 pi r squared times h. So we just need to know r and h. So that'll be our formula that we'll go through. Let's look at this particular problem. Again, h has to be the inside height. 12 is the inside height, so we're in good shape there. We have that r is 9. We know that h is 12. Okay, So we just kind of had this number pop up, but we'll go through it again. We have 1/3 of 81 pi times 12, which is a lot like one we just punched in. It was the same one I said here. You could do it as 4 times 81. So 4 times 81, since 1/3 times 12 is 4. So this would be 324. We're not putting the pi in the calculator. Our unit is something, cubic centimeters. Okay, so the pi is already in there for us. We just type in 324. Okay, all right, now this cone, if you can tell what's wrong with it, we have the wrong height. So we know so far what r is. We know that r is 6. But we don't know what h is. We know what L is, right? So we need to do Pythagorean theorem to find h. So again, here's our triangle. We don't have to worry about cutting this in half this time. This is the radius. So we have 6, we have 9, we have h. Okay, so we're going to do h squared plus 6 squared equal to 9 squared. Which is h squared plus 36 equals 81. So h squared is equal to 81 minus 36, which is 45. Okay, so we're doing the square root of 45, which, as you can see in the calculator there, is 6.71. So that's what I would go to put here, 6.71. Or 6.7. I'm sure either answer is actually in there. I'll make sure when I go through. So we're going to put a 6.71 right there. I'll make that. All right. And we're ready to go to the calculator. So we're going to take, and I'll even leave it exact here. We'll have 1/3. We are leaving this in terms of pi. So we have 1/3 times 6 squared, which is 36. Okay, so that's 36. Where's my calculator? All right, times 36 times our square root of 45. So 80.49 looks like I would put that in there as 80.5 times pi. They still didn't want us to put the pi in for that problem. Okay. All right, moving on here. Now we're on number 14. Looks like they gave us everything we need to find the area of the volume of a pyramid with no picture. We're going to round to the nearest tenth. So we have, for a pyramid, 1/3 capital B H. We know it's a pentagon on the bottom, so it's really going to be 1/3 times 1/2 ASN times H. They did give us the height. It would have said slant height if it was the wrong height, but we are good there. So we have everything we need. We have A, the apothem, which is, I want to just get rid of one thing here. Oops. All right, so they gave us A, which is 6.1. They gave us S, which is 8. And I didn't want to close that parentheses yet. They gave us the number of sides, because it's a pentagon, is 5. And then they gave us the height, which is 10. So let's worry about getting just capital B here. Let's punch that stuff in. So we have 1/2 0.5 times 6.1 times 8 times 5. So 122 is our capital B. So then we can go to the calculator for the rest. We have 1/3 times 122 times 10. So 406 it said nearest tenth, so that would be 0.7. I forget again. I always forget what the units are. We're in cubic inches. That's our volume. So that one, there wasn't any tricks there. They just didn't give us a picture. So if they do that, then just read through it, make sure you know everything, and then go. All right, sphere problems. If they're just asking you to find the volume, very fast problem. If they're asking you to do some other stuff with it, like the last couple that we have here, then it's a little bit trickier. So the volume of the sphere formula is 4/3 pi r cubed. All right, that's kind of a weird formula. It comes from calculus, so really all we need you to know is that that's what the formula is. Just kind of trust us on that. The nice thing is the only thing in this formula that ever changes is r. 4/3 and pi are just constant numbers. So the only thing you need to know about a sphere is the radius. So if I don't give you that, you're really gonna not have much luck doing the problem. 14 is the radius for this one. So we're gonna go through 4/3 pi. We're putting 14 into the formula. We're cubing that. So these are usually just calculator work. They do want us to leave it in terms of pi again, so we're not going to put the pi in the calculator. So we have 4/3, and then I'm just going to do the 14 to the third power. So that is equal to 3,658, again 0.7 if we're rounding that to the nearest tenth, and then we still have a pi in there. So that would be our answer for this one, and our unit was cubic meters. Okay, so let's type that one in, 3658.7 times pi. Okay, the volume of this sphere, they gave us the diameter, so we got to be careful about that. But like I said, the only thing that's going to change about this formula is going to be r. So 4/3 and pi are going to be the same every time. What's getting cubed this time is not 22, it's 11, because the diameter is 22, which means the radius is 11. So we're going to go to the calculator. I'm just going to change the 14 into an 11. So this one, in terms of pi, is 1,774.7 pi. Okay, that one is also in cubic meters, and we have our answer. Okay, 1,774.7. Okay. All right, the last one for sphere here, just pay close attention to. It was in your notes. Okay, so we did try it there. Let's look at how this will work. This is a pretty tricky question here. So here's what they tell us is going on right here. There we go. So what they told us is that the sphere that we have has a volume of this, 324 pi cubic centimeters. They want the surface area from that. So I broke it down into steps here. Step 1 is going to be find the radius. Then step 2 will be, if we remember what the formula is, pretty fast. So here's how this is going to work. Some kind of tricky math here. We have the volume equal to 4/3 pi r cubed. Now we don't know what r is. That's what we're going to be able to figure out. We know the answer for the volume is 324 pi. So I'm going to put that here on the left. And this is the situation that we are in. If we can figure out what r is, then we can plug into the formula for surface area, which is pretty quick. So I'm going to solve this for r. I'm going to try to get this all by itself. Okay, so let's see how we do that. First step is going to be to try to get the 4/3 and the pi over to the other side. So to get rid of this 4/3, I want to divide by 4/3. When you divide by a fraction, it's like multiplying by the reciprocal. So, oh, messed that up again. If I take 4/3 times 3/4, I get 12 up top, 12 on the bottom. These cancel out. So I'm going to multiply both sides by 3/4. So if I take what 3/4 of 324 is, that would be 243. So 243 pi is equal to pi r cubed. If I divide by pi's, they will cancel right out. So I have 243 equal to r cubed. So here's something that maybe you didn't know until we did it in the notes. The way that you get rid of an r cubed, kind of like getting rid of r squared, you would take the square root. We're going to take something called the cube root of each side. That's going to leave us with r on one side. And you can do a cube root on this calculator I have on Schoology. You just use this one with an n on it. So the cube root of 243. So we have 6.24 for our radius. Okay, so we know the answer to step 1, 6.24. All right, now the surface area stuff isn't so hard. So step 2, this was from last chapter now. The surface area of a sphere is 4 pi r squared. So that's equal to 4 pi times 6.24 squared. So that's just calculator work. Let's see, here we go. So we have 4 times, and we're not doing this in, we're not doing this in terms of pi, we're punching it all in. 4 times pi times 6.24, and we are squaring that. So we have 489.3. Now this is in square units, whatever our units are, centimeters. And we have our surface area. So step 1 for that, it might not tell you step 1 and step 2 on the real test, okay? But step 1 is find the radius with this cube root thing. So just pay attention to my steps there, rewatch it if it doesn't make sense, ask your teacher if it doesn't make sense. But once you have r, the formula is pretty simple. So maybe put this formula on your note card too. All right, so let's do this last one, volume of a cone. See if I can get rid of all my ink here. All right, so they told us the volume of a cone. Okay, so as soon as I see this phrase here, I'm going to look up that formula. All right, they told us the radius. They want to know the height. So here's what we do know. We know what volume is, so we know what goes on this side, 64 pi. They told us the radius, so we know what goes in for r squared. What they want to know is h. So we have a bunch of numbers on the left and right. We have one letter, which is h. We can solve for h. Not so bad. So the way to get rid of a 1/3 is to multiply both sides by its reciprocal, which is 3. 1/3 and 3 will cancel. So we have 64 times 3, which is 192. I'm also going to do the 4 squared in this step, which is 16. All right, and then, so I'm going to take that 192 then, that 192 pi, I'm going to divide this side by 16 pi. If you do this in one step on your calculator, be careful to put parentheses down there. All right, but my calculator will know what's going on. What's going to happen is these pi's will cancel, everything over there will cancel. So really we're just doing 192 divided by 16, and there's our height. We have 12. All that's left on this side is h. So that's how you go backwards to find a missing height in a cone, 12 centimeters. All right, that's our practice test. Feel free to ask me any questions that you still have, and good luck.